right, everybody, welcome to our office hours for the IBM Cloud or IBM Garage Cloud Native Toolkit. Today we're talking about Git 201. So beyond just the basic Git, what are some for managing Git repositories? This is kind of a precursor to the how to contribute to open source projects. Thing that we're going to do next week, but we decided in talking about what would go into that there's some basic Git understanding that's missing, because in general I find that a lot of people do the very basic Git and don't quite get past that. So some things like rebasing and some others are a little scary. So we're going to go through that. I have a couple, we'll do it based on scenarios, a little bit of intro for this kind of setting up just some context, and then we have a couple scenarios, common scenarios, and how to handle them with some maybe more advanced procedures. So to start, for just an overview of Git, this is the way I like to think of Git. It's definitely more complicated than this, but if you think of Git as basically just a linked list of each node has a parent, it has a message, and it has the Delta code. And then those three things together make up your unique ID. Now it really is more complicated than that. There's other stuff going on, but with that model in mind, it helps to conceptualize a lot of the things we're going to be talking about. So what that means then is if any of those three things change, you change the unique identifier, you change the commit. And the unique identifier is that hash, that big long number that sometimes is scary looking, but that's the unique identifier for a particular commit. So anytime you change any one of those things, you change the commit itself, it becomes a new thing. And that comes into play when you start talking about remotes and synchronizing them. And if there's any questions as I go, please feel free to ask them. So a remote repository is just a copy of the repository stored on the server. The thing with Git is each repository, each clone, the public is potentially a full copy of the Git repository. I say potentially because by default it is. You can prune it when you clone it, you can do a shallow clone, whatever, but the default clone, you get a full copy of the repository on your local machine. And then pulling and pushing commits is just reconciling the commit nodes and that, the linked list between the remote and local. So it uses those commit hashes to know where the shared history starts and where there's discrepancy. If you've just added new commits to one repository and you're just going to push, then that's a simple thing. But if the histories start to diverge, that's when you start getting issues of having to merge or rebase or whatever. There's a remote. So any of the remote names, origin is the default in the convention. It's just an alias for the repo URL. You can add any number of remotes. You can call them whatever you want. And origin, as I said, is just the default. But there's nothing special about origin. Now that said, there are a lot of tools that assume you've called your base remote origin and will work off of that. But it's just a way to identify here's remote and here's a name for it, so I don't have to type the full URL every time I want to do something with it. And as we
a lot of open source projects is there's a origin meaning your fork and upstream. They use the keyword upstream.
And you can with the same remote have a separate. You can separate the where you fetch from and where you push to. So you can have different endpoints between where you pull and where you push. So when you're talking about a fork, there's a pattern there to simplify how you synchronize changes from. I haven't quite figured out.
Yeah, I was forgetting about that.
Yeah, what the terminology is, the original repository, and then you create. It's usually I don't know if there's a formal way of naming those things, but you can pull from the original and push to your fork, so you can set that up with your remotes. And we'll show a little example of that in a minute. But really, again, it's just a URL, it points somewhere. You can have any number. I mean, you can synchronize changes across multiple repositories at the same time if you want. Like if you have an internal repository and a public one, and you want to publish only a subset of things out whenever you want to, you can do that. So branching strategies, I'm not going to get into any detail on this, and I'm not going to try to justify or explain, because there's a lot of, as Carlos is showing, a lot of contention here. My only point is there are different ways to manage your repository, whether it's trunk-based, where basically there's only ever one branch, which is master. Everything goes against that. Feature branch, which is kind of, you have a short-lived branches that you use for feature development that get merged in. And then Git flow is where you have permanent branches that live forever. And some can get very complicated, right? I mean, this is one where you get feature branches that live for a long time, and tagging on mass. I don't know. It gets very complicated. So there is a time and place for each of these, perhaps.
I don't know if you want to go over them or not. Maybe examples of each one.
Yeah. So, and a lot of what we're going to show is feature branch. So trunk-based is some of our garage projects use it. So I'll say first, particularly for the first two, trunk-based and feature branch, it always works best if you pull new code in frequently and push code out frequently. So the longer it goes, the harder it is, regardless of what you're doing. So everything works. And so if you're working on very small user stories and you're able to push those, you don't want things that last for weeks and weeks, because it gets harder and harder to keep it in sync. So the idea with trunk-based, part of the motivations for doing that is so that you are continuously integrating. There's never any diverging path.
Rebase is used a lot in trunk-based. Rebase, because there's only one master or one main branch.
Perhaps it depends. If,
in one repo, and you could have your own repo with multiple branches.
That's right. But there could be a lot of so the way it's done on some garage projects, right? You're working off there's one repo, you're working off of it, you're making your change on master, and you're committing. So either you can handle conflicts with a rebase, or you can just have a bunch of merge commits. I'll say from the start, I feel like your Git commit history is as much documentation of your code base as anything else you do. So having a clean commit history, to me, is very important. And so it's easy, if you're not careful, to get a very polluted commit history if you're doing a bunch of merge commits and all that, right? So that's where we're going to talk about rebase, and that's a way to keep your history cleaner.
Rebase and switch. Yep.
Yeah, and so feature branches, is where, and a lot of open source projects will use this, but where you create your branch off of master for the feature, you make your changes on that branch, and ideally, if that branch is living anything, at several points during the day, you would pull in new changes by rebasing your branch off of master to see if anybody has made new commits. And then when you're done, you merge that back into master ideally through a pull request, or you can do a direct merge on the branch. But that gives you an opportunity to, and we'll show this as well, you can rebase your branch to clean up your commit history, so that it gets down to a couple of meaningful commits, one or more meaningful commits that describe the feature that you've built, instead of having I know we've all done it, where you put the trying this, no, backing that out, trying this again, backing that out, right? It becomes very difficult to see what all happened. So then you can squash all that down and say, this is just the change that goes into this feature. Now, if you want to preserve that history for, your own education, or, to be able to go look back and see, oh yeah, these are the things I tried, then you can always keep that in a separate branch. But the feature branch can then be merged, and then that just becomes part of the history. If you use rebases and merges properly, it'll look like you were doing trunk-based development all the time, because the history will be clean, but it will have been done through feature branching. And then, as I said, Git flow, you have multiple permanent branches. We use this for GitOps. It's one model for doing GitOps when we do deployments in Argo. So we'd have a branch called test that contains the configuration that deploys to the test environment, and a branch called staging that contains the configuration that deploys to staging, and maybe master, or maybe you have production as another branch that represents your production state. And so then you can use pull requests to move changes from one branch to the other. As new versions are available in test and you want to promote them up, you can promote them. This picture here, this is where those permanent feature branches, or long-lived feature branches that are being merged repeatedly, that you have release branches that hold state. To me, that's a bit overkill, because Git has other facilities to do that. So that the other thing, if you think of Git as a linked list, then a branch on some level is just a pointer to a particular commit, and a tag is as well. It's a special kind of pointer. So you can have pointers to state, and then if there's a change to be made, you can branch off of that, make your change, and put it back. So on some level, I think having all of these feature branches is long term is unnecessary, but there are places where you do that.
Yeah, a place you will see this a lot, and it makes a lot of sense, is I don't know if you call it open source or production code, is to have a mark of a version of a major version of the release of the product. So for example, Kubernetes 1.17 or Knative 13. That if you create a branch, and then you can have a release where you release that branch, and you can have a tag, and then like Sean says, it's the same thing. But that at some point in master, you would diverge from that branch, but you want to keep that branch for users that are using an old version of your product. And if there's and this is for just for production code, or either release code, like big projects, right? That you have to have a CVE, for example, a security fix. For the most part, you want to leave that branch and never touch it again. That's in the past. You always work in master. But if there's a customer, there's a need that somebody like cannot get to the latest version, needs a CVE, a CVE security patch, then you can cherry pick something from master and put it in that branch. And then at that point makes sense, because it's totally a branch. It diverged the linked list from the master trunk, and it's now its own thing. So now if somebody wants a reference to that software with that version patched, they can get it from there, and then maybe in a week or so they can just move to the latest version, and then that's just there sitting there doing nothing. Historic reasons.
And that's more out of necessity than like this picture. Yeah. This picture shown, it's like they're doing it intentionally, which I think you're setting yourself up for trouble. But doing it out of a necessity, hey, I need to do a hot fix on and create a branch of this particular release that makes sense. And then cherry pick, I don't have an example of that, but we can work through that, which is basically just copying a commit from one branch and applying it to the other. So you pick up the, as I said, there's three things essentially that make up a commit. There's the parent, the code change, and then the message. Well, if you do a cherry pick, you pick up potentially the message and the code change, but it's a new parent, right? And if there's a conflict, you can resolve it as a part of the cherry pick. So again,
question.
Yes.
Carlos, one thing I don't understand about the example you just gave is I thought that's what tagging was for. So it seems like when you have a major release of the software, then you want to tag it, and that way you can go back to it a couple months later if you need to. But I don't understand why you need to keep a whole nother branch of it if you've got a tag.
Yeah, so so this week you would tag it version 1.2.0, and then you will have a version of that software. But then you start doing changes, incompatible changes on top of it, of that software, and somebody wants version 1.0, but it with only a security fix. So at that point, you don't know how to give that person version 122, version 121, like with only that security fix, because you're already a master like 100 commits already. So you need to, there's no tagging that you can do 1.2.1 because that CVE is sitting in 100 commits afterwards. So what you need to do is cherry pick that commit that has the security fix and then apply to that tagging of 120, that old version of the software, and create a branch, because there's no other way to put it. That makes sense.
Right, right. So it seems like rather than having a branch for 120 just sitting around in case you ever need it, instead it seems like you could just
At that time, yeah.
tag it 120, and then a month later when you decide you need to do you're running into this scenario, then you create a branch off of 120 and do the patch the way you're describing.
Yeah, Bobby, that I would do it like that, but for historic reasons, people have scripts and assume they're branch. They have all ways of doing it, so you're hit point on. And also consistency, like we always do this the same way versus having an if statement in open source projects. People go off, they go on even in production products. Like people join the squad, they leave the squad, and then having that if statement sometimes it's like difficult, right? You always create a branch, release, and you run the tool against that release branch. But at the end of the day, you got it. It's just a tag. It's a reference. It's a ref.
Okay, so instead of trying to figure out if there already is a branch for the tag, you just automatically assume there is a branch because there always is a branch for the tag.
Well, you
For
can,
the
yeah,
major
you
release,
can
so people
create,
would do it like they would call it. It's different patterns. So I'll just end with this. So one pattern, and it could be many. It's like you create a branch called 1.2.x. You don't even give it like a version number, like a 1.2.x, and then anything 1.2 dot something goes into that branch. So the branch doesn't even have a version; it just have 1.2 dot x.
yeah, you can make a branch. So to make a branch, I mean, by default, it goes off, it branches from the current, the current commit you're on, but you can branch from any point in the history. So you just need to pass it an identifier for that particular commit. And so a tag is just a special type of identifier. It's basically an alias, a named alias for a particular commit hash. So you can,
for the whole hatch commit.
right,
Yeah.
right. So you just pass that in, and it'll start a branch from that point. And again, the branches and tags are flavors of similar things, since they're pointers, but branches are handled a little differently, since it assumes you're making changes on them, and they show up differently in the list. So creating a tag first and then creating a branch when you need it is kind of the most ideal, if you ever need it, right? A lot of tags you would never branch off of, and you wouldn't have to mess with it.
Okay.
So there's a couple commands we're going to use that I just wanted to go through them. Fetch. I know there's some confusion, the difference between fetch and pull, right? So fetch retrieves the changes that it goes out and looks at the remote, sees what changes are there, and pulls them down. So they exist on your system at that point, but they aren't applied to the current state. So pull does both fetch and merge, right? Or it applies it to your current branch. So that if ever you see, you're looking at a remote and you say, hey, there's a branch there, and you locally try to check out that branch, it says it's not there. It's because your local system doesn't know about it yet. You have to do a fetch. And many times it's preferable to do a fetch first and then do a get status to see if anything is diverged. So status will then check, it'll say, hey, you're missing 2 commits. It's because it did a fetch and it knows, hey, it's local. And then you do a pull. But if you diverged, it would tell you have 1 and there's 1 remote. You need to do something about that. So typically you'd want to do fetch first. Reset. It just moves the pointer of, well, let me say first, whenever you run a command in Git almost always, and I say that because I'm sure there's an example that isn't true, but I don't know of one. Almost always that command works against the current branch you're working in, right? So it's the target is always the branch you're on, and then you provide other parameters to tell, hey, I want to rebase from this branch, my current branch on top of this other one or whatever, right? So if you do a reset, you're basically moving the pointer to a different commit, whatever you point, and that could be a commit hash, that could be a tag. The --hard means any changes, any commits in between where I am and where I'm going, throw them away. So if I'll show you the scenario how I use that at times. Basically just, hey, lose those commits. I just want to reset hard. Now reset soft does the same thing. It'll go, you want to go 3 commits back. It'll go 3 commits back, but it'll preserve all those changes that were in those commits. They'll be staged, but there won't be a commit. So then you can modify them and recommit them. So that's, one scenario is if you commit something and right away you realize, oh man, I missed this one. One thing you could do is reset soft back to the last commit, add that file and redo the commit. And it's like the original never happened. The reset hard is if I've done a pull, and this is one of the scenarios we'll do. If I made a change accidentally on master, and I committed to master, and then I realized somebody else made a change, I can put that change in a branch, go back to master, and move the pointer back to before my change, and it's as if I never did. So that's easiest to show an example of that. And then rebase, there's 2 flavors. I mean, there's a bunch of flavors of rebase, but there's 2 in particular we're going to use. One is if you do rebase and provide a branch name, basically it reparents. That's my word, I don't know, but basically it says
replace.
Well, it changes whatever your original parent was and it moves it to the latest commit on that branch, and then rebuilds all of your commits on top of that.
Yeah, I call it replay because it moves the pointer and then start replaying the commits as you were putting them into that reference.
Right. Yeah. So what it means, because you're changing the parent, now you are creating new commits. So that's one thing. So to resolve it, you have to force push. The other thing is, because it is replaying each commit, at each point, if there's a conflict, you're going to have to resolve it. So basically, you're rewriting potentially the commit that you made. If you made a change and somebody else had made, that was part of a larger change, somebody else had made that same change, you would basically rewrite your commit to take your change out and you use the one that the other person provided, and now you've got a simpler commit that you've made. So that rebase, and then one more, rebase interactive, the -I, that allows you to see the commit history, everything that changed up until the commit you give. Again, that can be a tag, it can be a hash, and you get a listing of all those commits, and then you can modify them. You can reorder them, you can squash them together, you can change the message that you provided, and I'll show an example of that. So with rebase in particular is a very powerful tool for keeping your Git commit history clean. And I had mentioned a common pattern would be you create a branch, you make a bunch of changes, and you do whatever, right? And at the end, you've got working code, and then you rebase interactive to get those down to a clean set of commits with good commit messages. Maybe you add in your issue number if you forgot right before, and then you rebase off of master to make sure there's no changes that you missed, and then you create a pull request that gets merged in. So then you get a very clean set of commits that go in.
And take all those 20 commits that only say update, like I do.
Yeah.
And squash them into like update the thing, fix the issue, blah.
And it doesn't have to be one big commit, right? If there were like several logical things that you did, it could be this one, maybe it's by file, or maybe it's by the type of changes we made. You combine them together.
The testing first, right? You did all that. If you're doing TDD, all the testing work, you say like finalize all the testing for this feature, and then the second one is just the code for the testing.
Yeah. And usually I gauge by what I'm putting in the commit message to know if I'm putting a bunch of stuff, then maybe this is 2 different commits. But it depends on what your target is, especially if you get into, hey, I start working on 2 issues at the same time. Well, as best as possible, separate out the other issue logic and do them separately. So those are the common commands.
It's very useful. It's also, if you see, it's an up best practices. If you see a lot of commits and you're trying to describe it and you're putting a lot of words, you start thinking like, oh, this should have submitted this like a day ago, and then work on this other stuff. I hold too much too longer, and then now I'm fighting to fix conflicts, right?
And if you can, and if you can reorder it and take the small piece out, move it to the beginning, maybe even put that in a separate branch and do a pull request on that.
And then continue on the other piece that you're not sure, you're still working on.
Right. So yeah, there's a couple of scenarios there, and we'll show some of those. So recommended tools, I would say shell annotation and autocomplete are important. Let's see if this will show up properly. No, I'll show it in just a second. My screen share won't let me switch over. But basically being able to know what branch you're in, what changes you might have, right? There's different shells, plugins that'll do that. But after using one like that, I went on somebody's machine that didn't have it, and I was pulling my hair out. What branch are you on? What's the state? I don't know. So it's very helpful.
I don't know.
Yeah. It's very helpful to have that. Source tree is one.
Yes, I love this. I cannot do anything in Git without visually having a visual. I love it. Once I discovered this is my tool.
Yeah, so it's free. You have to create an account on Atlassian. We all have Jira accounts anyway, so it doesn't matter. But it's a great tool to visualize your commit history, and I think if more people use this and they saw how trashy their history got, they would
yes, it's a mess.
Learn more. I saw Sean's name there and saw my name in there, everybody who did this, Sean holding on that branch for a week saying that it's ready. I see like the dates that he make changes.
Recommendation, stick to command line. This is a mess, but then very nice mess, nice colors.
Well, and I'll tell you this, when I was first getting into how to rebase interactively, there's a great tool here inside SourceTree that rebase interactively that lets you visualize it better. So I would, when I first started doing those rebases, I did it all through SourceTree, and as I learned the process, right?
Oh, I want to see that. I always do VI or VS Code and edit, like select all, fix, but yeah, I didn't know about that SourceTree.
So GitHub Desktop is a nice way to visualize it doesn't have the tree view. That's the problem. And then get to know your IDE tools, because IntelliJ has a great Git set of functionality. VS Code does as well, and take advantage of those, especially when you start resolving merge conflicts. You can do it in VI, but it is using IntelliJ or VS Code is a much better way to do it. And again, the more frequently you do it, the easier your conflict resolution is anyway. So the longer it is, the more changes there are, the harder it is. So I'll show you so Git aliases. This is because I'm going to accidentally use one of these in just a minute, and I want you to understand what happened. So I use Git aliases all the time. I have a set, and I have a link here to a gist that has all mine if you want them. So you can do simple aliases like this. CM is commit -m, so I don't have to type it all out. Checkout, CH. CHB is checkout FB. And then push force. So when you do a push -force, and we'll talk about this, there's 2 flags. One is -force, and one is force with lease. Force with lease is safer, but it's a lot longer to type out. So I just have PF, and I don't have to type any of that. Then the reason it's safer is because force with lease will go out and check the remote and see if anybody else has made commits while you were making your commits, and it'll say, hey, you shouldn't force push because you'll lose code out there.
I share my only one that I use, that is the one that I don't have to think about, that is I'm working on my fork and I want to update it based on upstream master and rebase it. If not, then I don't know. I do this like every day, every time I start working because I want to know I have the latest always when I start typing in my keyboard. This is something I learned. I didn't create it. Somebody created this for me. And
that gist is curated from things I found along the way and said, oh, I want to add that. So I didn't create many of those by hand. But so there's it's in the .git config as an alias section. So you can add an exclamation point at the beginning, and basically it just drops into a shell, and you can do whatever. So this is add and commit with message. I use all the time, but it's actually used within other scripts I have as well. So that basically lists your current branch. So if there's anything that you need the current branch name, like you want to push with the branch name, then you can use me. And then so up, I use that all the time. When I first create a branch, get up, that does push -u, right? And it uses the get me command.
that's a good ones.
Yeah.
And
and
the pound does? I don't get the pound.
The exclamation?
Yeah.
So the difference, right? This one, it assumes get at the base, and it just adds the command get command to the end. This one drops into a shell, so you can run any shell command you want after the exclamation. It doesn't have to be a get command. Like the echo is there, right? So if you put exclamation, and now it's just going to run a shell script. You can do anything you want.
I see.
But you have to add get to the.
Yeah, mine has a pound. I didn't notice it has a pound sh. Okay.
And then you can even, since you're in the shell, you can have a function that has even more complex things, right? Where you get parameters. So this one does check out a branch, pull the branch, go back to the original, check it out, rebase, right? So I don't use this one very much, but it's in that list.
Actually, that looks like mine.
Oh yeah.
Because I assume that I'm working in something upstream and I have my origins the fork always.
Yeah. So so again, you got the $1 and 2, so you can pass in parameters. So the first one is your branch. The second one is the one you want to rebase on top of. And that's the thing, when you do a rebase, you want to do a pull first, so because it works off of your local copy. Okay, so a couple scenarios, and these are just common ones I came up with. We can talk through some others as well. But so, you made a commit to a branch, or someone else made a commit to the branch that you hadn't pulled yet. You've made a local commit, and now you have, it tells you there's a diverging history. What do you do about it? Another one is, I've made a branch, I'm making my changes, and I know somebody has committed something else to master, and I want to get those changes. So you could do a merge, but that creates a merge commit, and that's ugly. You do a rebase, that gives you a cleaner history. And then cleaning up commits made in a branch, that's basically interactive. And then adding and removing a tag and working on the repository fork. We'll see time-wise how we get there. We might do the repository fork next week, because that's a big part of what we're going to do anyway. Okay, so I have an example. It's actually the one I just showed in source tree. I have an example repo. It's just a simple little Express Hello World app. But you can see here, master has 2 commits ahead of these branches. There are 3 branches, all of which exist on the origin, but I haven't checked out locally yet, right? But they're all pointing at the same commit to start with. So as we work on them, we'll see them diverge. But our first scenario is, and I've got 2 copies of this cloned down, demo 2, and demo 1. So I have, let's see which one I was in. Okay, so I'm 1 behind master because I had pushed it in demo 1. So if I were to, I have it here. Wait. have it here in IntelliJ as well. Oh, but that's a demo one. So let me go back here. So if I
So you
change
have
a
one
file,
you have one remote. Can you do get remote -v?
yeah, I have one remote right now, but I've cloned it twice just so I can simulate somebody else.
Yeah. It's just
Right,
remote
so-
-v is useful for people to know. Yeah. So now you know how to
Yeah,
reference.
so yeah, get remote -v, and this is where I was saying you can have a different fetch and a different push. By default, they're the same. And if when we get to the fork, I can show you either this week or next. So if I want to make a change to my index, and so the other thing, when you add dot, that's your current path in every subdirectory. If you only want updated files, you can add -u. You know, there's a couple of options there. They've also changed recently. Here's another thing I find. Git is very good at telling you what you need to do. I find most developers don't bother reading this message, and so they don't know what to do. But you know, right there, if I wanted to, I've staged that file. If I don't want to add it to the commit, I would just unstage it. It's easy enough to do at this point. It's easy to look past that and just not figure out. But Git is really good about that. So at this point, if I want to do a commit, I'm using my. I'll just do this. So now if I do get status, I've got diverging commits, right? I've added a commit and there's one commit.
Yeah, show any source tree so people can visualize.
Okay, yeah. Well, this is demo one. So this is the thing with source tree. You can use it to pull down remotes. I typically clone them from the command line and then I add existing local repository.
Yeah, that's what I do also from local.
So we look at demo, so we can look at these two side by side. Okay.
Double click it, doesn't happen.
There it goes. Okay. So you can see. Let me just go. So you can see the difference here. Expand from the bottom. So there's origin master, which is the same as this master right there in sync still. And now I've added a commit on top of that. Well, and origin master has that commit, adds IntelliJ to ignore, because this is where our histories start to line up, is on this fixes startup message. So there's a couple things that can be done here, depending on how you want to handle it. Typically, what I would do is just put that to a branch.
So I don't lose it.
You know, I'll put it in just a temporary one. So now, if I look at the history, so all I did was create a pointer, essentially, to that same spot. So now I can go back, and I'm still out of sync. So if and I know I'm one ahead because that's the first. If I say, let me just go back one commit. So if I go back one, and now if I go back here, you see I moved the pointer for master back a level. And if I do get status, I'm one behind, right? So all I did was I essentially moved the pointer. Now I can do a get pull. And if I look here, now my master got moved up to the version that was in the remote. And then now what I need to do, if I want to add my change on top, I'm one behind master. So I need to rebase my change to put it on top of master. So it's the, again, rebase, it's always going to change the branch I'm on. And I want this to be put on top of master. So if I do get rebase master, there should be no conflicts. And now you see the history lines up, right? It's nice and clean. And if I do a, so this is where you would typically do a pull request and get that in. You can also, though, if I do git merge my branch, I've now moved that pointer up. So now it's clean. It's as if I had made my change. I had done a pull and then made my change. So basically, I got myself out of a jam without having to pollute the history. The other way to do it would be to do
the merge. That's for people to remember. I always forget. It's like the git merge. The way it works is your current context. You're bringing that thing into the current context.
Yeah,
that's why you have to move first. And sometimes it's I get confused because of the order. And am I putting master into merge into SMS or SMS like?
Yeah, again,
one way of
it's always going
remembering.
to work on the branch you're on. So this is git merge SMS into master, essentially. Right. But yeah, that's it. Sometimes it gets tricky. What's the target? What's the source?
You don't have it in that one, but I at least on my ZH I have the status for 2 coming in behind 2, 1 up. Also,
yeah, I lost it when I did the I need to figure out how to get that back. This one changes color if you're out of sync, but it doesn't tell you the numbers. So I need to figure out how to add that back in. So, and it did what Git calls a fast forward merge, which basically just move the pointer. So if I do get status, now I'm one ahead, I could push that out. The other thing that could be done is if I do a so one thing when you do a git reset hard, you can lose content. So it's especially when you're rebasing, but when you're resetting, if you're not sure, I typically will create a backup branch. So git checkout branch like BK or something. So that if something happens, I can always go back. The history, the state is still preserved in that other branch.
yeah, they don't cost anything. Don't be afraid to have a lot of branches.
Yeah. And at some point, there may be some orphan commits you have to go purge, but that's not that big a deal. They don't take up those space. Yep. So yeah, creating branches to store stuff, especially if you aren't pushing them to the remote, then it's not a big deal. Well, actually, let me do this differently.
Push them to your fork in case your laptop goes and blows up.
Right. Yeah. So this is where if I do a reset soft, so that's the other way to do it. If I had my change, I could do a soft, a soft reset, and so now my change is there, and I can do git.
That's the default, right?
Soft. I think it's mixed, but yeah, I usually do it explicit. But yeah, if you leave it off, it's soft.
The way I do it is I don't put anything git reset to master because I by mistake always make the mistake of checking into master because I forget and like I didn't want to modify master, so I git reset to the like what it matches the remote, but I have my files. I still want to have my files sitting there.
Right. Yeah.
So that's what you have there. You have modify file, so your files still exist.
So the other way to do it is if you do a reset soft, if there's still stage, you can do a stash, which put that commit away, and you can do a git pull. Right, there aren't any more changes, but do a git pull, and then do a git stash pop to put it back on top. So, and if there were any conflicts, you resolve the merges. So that's the other way to do it without having to create a separate branch, rebase, and move it is.
Or a commit, you just like files, moving
Yeah,
files,
but
stashing files. Yep.
you do have, you see, I did lose my commit, so I lost my commit message by doing it that way. So I'd have to recommit that file. So if there were several commits in particular, or if there were, you spend a lot of time getting the right commit message in there, you don't want to lose it. You use the branching strategy. If you just made a commit and then you realize, oh, I messed up, then you could reset back a level, stash it, and pull and then pop. So that's one way to handle that. So I'm going to do two real quick because we're going to run out of time. But so if this is one that's best seen through through the here we go, through source tree. So one, we just did rebase, so it'd be essentially the same thing. That scenario where pickup commits made to master while making changes on a branch. If I do, it's pretty simple, but if I check out scenario one, that's the and I do let me make sure I pull master first. So if I do a rebase now, so it's going to replay those commits. Now there was you can see it goes through one commit at a time. And if you look at my commit history here, changes to port 3001. That was the first one. Changes back to port 3000. It played that one. Updates to formatting. It played that one. And in doing that, it hit a conflict. Well, but it had conflicting, or it had changes in both, but it was able to auto resolve that, right? So it auto merged that change, and then gets name from path. It worked that out itself. Adds lost handler for slash. It worked that out itself, and then at the end, well, okay, so it wasn't the slash that it had a conflict. So if I do a get status,
It will tell
tell
you.
me both files were modified, or both branches modified this file in a way that it couldn't resolve itself. And then it also tells you what to do about it. Right?
Everything's there. Just read it.
Yeah. Fix the conflicts and rerun, rebase, continue. So fix the conflict, add it, and run continue. It'll go on to the next commit. If this is the one tricky part, if there were no changes, like if you ignored your changes, then it won't let you do a continue. You would have to skip. But if you didn't want your change, you say mine's invalid now, I just want to skip my change, you would just do rebase skip. And if you get in the middle of it and it's hairy and you say, I wish I'd never done this, you do abort and it puts you back to where you started. Yeah. So if I go into IntelliJ, let me move that over. This is one I discovered fairly recently. So if I right click and say get resolve conflicts, and I know VS Code has something similar.
Yeah, yeah, has you click on the change and it give you the two.
All right, so this will list all the change files. If you know already, hey, throw mine out, then you can accept theirs. That's what came in on master. If you know already, hey, throw out the one from master, I know mine is right, accept yours, or more than likely you merge it. So you view the file, it lists.
This is the view.
Yep. Yeah, so this is master on the right, already rebase commits and commits from master. On the left was the commit from my branch, and then this is the result, right? So you see,
final thing that you want.
This one, I want to add this in. So you either X, in IntelliJ, it's X to ignore it or arrows to apply it. You can apply both. In this case, we want to apply both. I don't need 2 copies of that though. And you can edit in here. So now we've got a clean.
VS Code offers the same similar thing.
Yeah. Now the one thing with IntelliJ, you have to address every single change. So either the arrow or the X on both columns all the way down, or you can do this apply non-conflicting changes where it'll do all that for you. But to be able to apply this cleanly, you have to have addressed every change. So now if I apply, and if I do get status, you see, okay, now there's a commit. IntelliJ has added it for me. If you're doing it yourself in VI, you go into VI, you make the changes, you save it, and then you have to do a git add of that file. So now it's ready to go. I can run rebase continue as it's told me to do, and it'll move on to the next file, update startup message. I've got another conflict here. And if I do, right, so you can see that's the conflict. I can fix this. This one's fairly straightforward. I can change this myself, or I can do the git.
Yeah, you get the VI way, like change the markers. Yeah.
Or I can do it this way. So this was my change. That was the change over there. Pick which one you want. And then I'll pick that one and I'll ignore that one. And then apply. So now, if I rebase continue, you see you got this weird hash kind of in the syntax because it's still in the middle of a rebase.
In the middle of that commit, yeah. So you don't need to kick commit at this point. People do that mistake. Yeah. They don't understand they're inside a commit.
I think it'll tell you, hey, you're not done rebasing. Run this instead. So now, so you can see I've diverged. If I go back and look,
source tree.
Yeah. So you can see.
That's why it's useful. You see, yeah.
Yeah. So this is where we started. Scenario 1. It was pointing. It was this was the parent, and after our rebase, our local branch is on this parent with no changes. That's why ours is 8 ahead, because there's 8 commits since we diverged, and this one has 6. So now if I want to apply that, this is where you have to do the force push. So let me just do the status to clean it up. So this is where I was saying the cleanest and safest way to do it is do force push. Or
you said the cleanest using force.
Yeah. Well, it's the safest way to do a force.
Because you know what you want, right? This is what I want up there. Yeah.
So, but that's the thing. I mean, typically, if you're doing a rebase, you should be doing, number one, you should never do it on master. If you're doing it on a branch that is likely private to, or specific to you anyway, so then you can do a force without worrying about it. But if you're working on a shared branch with somebody, you're both kind of playing around with changes. And you want to make sure you don't accidentally override any of their changes. You do force with lease. That will reconcile the commits, and then when we come back.
With lease, what does with lease does?
It checks the remote to see if there's any other commits that have been made to the remote since you made
new stuff. Okay, I see.
So it'll make sure that you don't override anybody's new changes.
Yeah, I was working with my own stuff, so hopefully nobody has my password.
Force will just blow away anything. It says make the remote look exactly like this. I don't care. Force with lease has that extra check. So like I said, it's safer. But for the most part, if you're working on your own, it's not going to be a problem. If I do
your own fork, yep, because.
So now
that's why I like the having the 2 remotes. I have my origin, which I can blow up. I can do branches, is my private stuff, and then upstream is the one that I'm sharing with the world.
Yeah, let me do one more of the interactive. So I'll do it from here. So if I want to check that out.
I want to see this one.
So you go down to the root here, and you say, so I've got scenario 2 checked out. So that's the one I'm going to work on. I say right click and say rebase children interactively. So now it gives me a list of here's all my commits. So if it's this is the oldest, this is the newest. So I have a couple of options. I can reorder them. Right.
Yeah.
and then I can squash with previous. Now the thing is, it doesn't distinguish between
Fix up versus
and
squash.
squash. So everything is a squash, and then you can edit the message here and
Okay.
clean it up, right? And then if you get in the middle of it and you have a problem, you can cancel it. Now, one thing I found, if you're
What about the
reordering
conflicts? How are you going to deal with the conflict here?
it'll tell you
Give you
pop
the
up and say
the
there's
three-way
conflict.
window.
Yeah, there's a way you can resolve it here. To be honest, I typically go back to the
Yeah.
to IntelliJ for that, just because it's more comfortable. But you could do it in here. The other thing I find, particularly if you're reordering things, to do that one step at a time, because if you're not careful, you can create conflicts when there really none exist if you do it in the wrong order. So
The order, yeah.
yeah, so you can reorder your commits. That means if you had a change that was early, but or that you made very recently, but you want to merge that in, you can either cherry pick it and copy it over, or you can reorder them, put that commit at the bottom, the very newest commit, and then merge just that change over and keep the rest of your branch. So there's lots of, or if you want to move changes, so related changes are next to each other, so they can be squashed down, then that's the other reason to reorder. So this is how it looks here. If you do it from here, again, you need the commit, and I want to go back to
this one. Is everybody there?
Yeah, we're here. Something just happened with your headset.
Yeah, my AirPod just died. It's been a long morning already. So basically you need the hash, and if I do get rebase -I, and I want to tell it basically starting from where, now I get, the default is VI. You can change the default editor if you want, if you're not comfortable with VI, but this is the same view essentially, but it a little bit confusingly, they're in the other order. So the newest, or the oldest, is at the top. The newest is at the bottom. And so if, again, if I want to reorder them, I can just pick them up and move them around. If I want to, you've got, there's commands and options for what you can use. I don't use a lot of these. The main one I will use is either squash or fix up. You can use edit if you want to change anything. So what that means is by doing fix up, it's going to merge the change in, it's going to throw away your commit message. So that just gets combined together with the previous one, and the message gets lost. If you do squash, though, it's going to give me a chance to edit, similar to what was happening in the source tree. Gives me a chance, if I save this, now it shows me each of those commit messages: updates, formatting, get name from path. All right, so I can put those together, maybe make a message like that and save it. So if I look now at what happened, right, again, it diverged, but all those commits, all those changes got put into one commit. Now in this case, there was one file involved, so that's not as interesting as seeing a bunch of files. But there's some other things you can do with source tree, like reversing the whole file. That means like if you want to back it out. So I'll do that a lot of times if I made a commit that's too big and I want to split parts out. You can reverse a file and then reverse it again. So this is not as interesting because there's one file change. And reverse again, which puts it back, and then squash the one that removed it down. So then now I've got a commit that doesn't have that change in it, and then now I have a following commit that does. So you can remove changes. You can even in this reverse hunks. So just in this case, it's one big hunk, but it'll break up if they're separated in the file. It'll split the changes into different hunks, and you can reverse just a subset of the file. Let's see if there's an example. Yeah, I made a bunch of small commits. So that's the the way you clean up your commit history, and then you can merge that change in, and all of those individual, like especially these where changes the port, changes it back. Those are things that you can fix up, throw away that message altogether. So, we're at time. It was adding and removing a tag and working with repository fork. We can do those when we talk about the overall process for working in open source projects. That'll particularly relate to the Cloud Native Toolkit work, but it would apply to any open source project, and quite frankly, probably to a lot of other projects in terms of how best practices should be done. Now, a lot of our garage projects still won't work that way in terms of everything is a fork, and you merge it back through a pull request, but still, there's the principles there are the same. So, are there any questions or any scenarios like in particular that you'd be interested in seeing real quick? Well then, thank you.
And one last ask. I'm still looking for the previous video. I miss alert, so.
Yes, yeah, I will. I'll
somewhere. Please let me know. I've been looking.
I'll send that. I owe the link to you.
Okay, thank you so much.
So this and the others, I'm behind from the last one, but we posted YouTube channel, and then we have a page. We'll get the details there. And the other thing, I need to follow up and put the playbacks on the events as well. So I'll do that.
That will help. Thank you.
All right, very good. So if there's nothing else, no other scenarios, then we will pick up next week with open source contribution. If there's anything in between that's come up, we can maybe address it next week as well. All right. Have a good day. Thank you.
Thank you. You too.